Now that our heroes have completed Bio Ball Z, our heroes now journeyed to the next section of science. But this terrain, it slaps all students sideways, differently, immaculately during their PPEs. Will our heroes have what it takes to conquer this last section of Paper 1? Find out in today's episode of Physics Ball Z. Here are the retrieval questions for this lesson. You know what to do. Aerobic respiration produces carbon dioxide and water. Fermentation produces carbon dioxide and ethanol. Anodes are positively charged electrodes. Cathodes are negatively charged electrodes. Condensation is when a gas turns into a liquid. Sublimation is when a solid turns into a gas. We need to make sure that you know all the different energy stores, so I've got 4 out of 8 of them here. See if you can match these up. Chemical, atoms bonding together. Elastic, materials being stretched or squeezed. Magnetic, magnets moving closer or further away from each other. Gravitational, moving towards or away from the Earth's surface. Technically, this could also be the surface of a moon or any planet or star as well. Now I have the other 4. Do your thing. Kinetic, moving objects. Nuclear, within the nucleus of an atom. Thermal, inert objects. Electrostatic, electric charges moving closer or further apart from each other. Here we have a car showcasing different energy transfers, and I've got these challenge questions for you to do. Do your thing. Cars get chemical energy from petrol. The useful energy coming out of cars is kinetic energy. The 2 wasted types of energy are almost always sound and thermal. The road and tyres are getting hotter from the friction, and you will also hear that wasted sound energy. Now I have these 2 images showing different energy transfers. Here are the challenge questions for these 2 images. Do your thing. The ball is above the Earth's surface and it's moving, so it has kinetic and gravitational energy. I should technically say gravitational potential energy. If you look carefully, you see that the man's face and the ball are both deforming. That means that elastic energy is increasing. As the dog drops down, it's getting closer to the surface of the Earth. Some of you would have probably thought that it was kinetic, but it's actually gravitational potential energy that's decreasing. The dog is actually increasing in its kinetic energy. Objects tend to accelerate when you drop them if they haven't reached something called terminal velocity, which we'll look at in Paper 2 Physics. Energy transfer diagrams show the input and output energy from an object. For example, as we saw, the energy input in cars is chemical energy, and the useful energy output is kinetic energy. Now have a go at working out the input energy and output energies for these different objects. An electric lamp will take in electrical energy and it will give out light energy. An electric fan will take in electrical energy as well, and it will give out kinetic energy, so those blades are moving. A speaker takes in electric energy as well and gives out sound energy. And a microphone is like the opposite. It takes in sound energy and converts that to electrical energy. We will look at 3 different calculations in this lesson. The first one is given to you, so you'll get this in your calculation sheet. Elastic potential energy. This is half times the Springs constant times the extension squared. Kinetic energy is half times mass times the speed squared. Gravitational potential energy is the mass times the gravitational field strength times the height. Here's a past paper question. In 1 minute, a mass of 9,000 kilograms of water flows through a turbine. The speed of the water is 30 meters per second. Calculate the total kinetic energy of the water passing through the turbine in 1 minute. Give your answer in kilojoules. Looking at the questions, we can work out kinetic energy when we sub in the half times the 9,000 kilograms times the 30 meters per second squared. That gives us just over 4 million joules. But we need our answers in kilojoules, so divide that by 1,000 gives us 4,050 kilojoules. Here's another one on kinetic energy. A car has a mass of 1,650 kilograms. The table below shows the kinetic energy of a car moving at 11 meters per second. Calculate the missing value in the table. Give your answers in kilojoule. Subbing the numbers is half times 1,650 kilograms times 30 squared. That gives us 742,500 joules, but dividing that by 1,000 to get in kilojoules will give us 742.5 kilojoules. In this example, we're calculating elastic potential energy. A different spring, obviously this is from a previous question in this past paper, a different spring has a Springs constant of 13.5 Newton per meter. Calculate the elastic potential energy stored in a spring when its extension is 12 centimeters. The equation is half times Springs constant times extension squared. So there's something you need to do here. See if you can work it out. You need to change the unit for extension to meters. 12 centimeters divided by 100 gives us 0.12 meters squared. Multiplying all of that gives us 0.0972 joules. In this next question, we need to work out the gravitational potential energy. We are given these 3 pieces of information. See if you can work this one out. Gravitational potential energy is the mass times the gravitational field strength times height. Subbing our numbers, we get 2.499 joules. This last calculation is no joke. We are given these 2 pieces of information and we need to work out the extension of the rope. Since you need to use the equation sheet, you should already know which equation we'll be needing. And that equation will be the elastic potential energy equation. See if you can work out the whole thing. First, let's sub our numbers. Now we need to rearrange for extension. To get rid of the squared, we need to square root the right hand side. That is equal to the square root of 400. When we work out the calculation on the right, and this turns out to be 20 meters. And there we go, mission accomplished.
Fatality.
Check out the description for the revision timetable or flashcards. I've also got flashcards on the different equations that you need to memorize, so make sure you check that one. It's completely free. Chop that thing. I'll catch you guys in a bit.